All right, this is a Lesson Master Worksheet 8.2b in a review of Lesson 8.2, and then we'll have a review sheet here for Lesson 8.3 as well. All right, so jumping right in, we are looking at power properties here. And so we're going to express this two different ways, an expanded form and then also as a single power. So for number one, this is 5 to the third times 5, and this is raised to the first power. And so if I'm going to write this in expanded form, this 5 to the third is 5 times 5 times 5. And that's being multiplied by 5 times to the first. So that's that. And I can simplify all of that to 5 to the fourth power. And so that's why the property holds true, that you can just add your exponents here when you are multiplying similar bases. So number 2, x to the third times x to the second looks like this. So there's 5 of them across, so it's x to the fifth with a single power. Again, adding your exponents. So here, negative 3 to the fourth raised to the second. So it's negative 3 to the fourth, which looks like this. Negative 3, negative 3, negative 3, negative 3, 4 times. That whole thing, this entire thing, is raised to the second, so it has to show up twice. So I have negative 3 to the fourth times negative 3 to the fourth, fully expanded. In essence, though, I just have 8 of these. So this is negative 3 raised to the 8th. And this shows your power to a power property. When you raise a power to another power, you multiply the exponents to get the final result. So number 4, x to the third is x times x times x. It's got to happen 5 times. It's 4, 5. Okay, now you don't need the parentheses, but this shows your groupings of x to the third, x to the third, x to the third, x to the third 5 times. Okay, and if you counted them, there's 15 of them. But the quicker way, of course, is to just multiply here. So that's what we're going to do moving forward as we simplify here on the bottom. So this is 8 to the fifth times 8 to the first. Power property says just add your exponents. That's a to the sixth power. B to the second, b to the fourth, that's b to the sixth power, adding straight across. Now, we do multiply coefficients. These had coefficients of 1, so they get multiplied. You still have 1. So here, this is 1 times negative 1. So I'm going to have a negative 1 coefficient here. If you want to put the 1 in front like they did here, that's fine. I'm just going to leave it as negative. We don't need the 1. C to the 7th, c to the 3rd adds up to c to the 10th. So it's negative c to the 10th. Number 8. Multiplying 2 times 5 is 10, and then you're going to multiply d to the first times d to the 9th, adding those exponents, and that is d to the 10th. Number 9, multiplying e to the third times e to the second, add your exponents, that's e to the fifth. F to the fourth times f, this again is to the first if you don't see anything there, and that is also f to the fifth, so both e and f to the fifth power. Number 10, coefficient of 1 times the coefficient of 3. J times j, they're both to the first power, so that's j to the second. And then k times k to the second. It's k to the third, because this is to the first, and that's to the second. Okay, number 11, multiplying your coefficients comes to positive 8. Adding your exponents, because we're multiplying, m to the 6th, n to the 8th. Okay, number 12. This whole thing is being raised to the third. Now, if we just look at the p to the 0 raised to the third, the power property says you're going to multiply. So you will still end up with a p to the 0, which equals 1. So that really just is going to go away. And we do have 6 to the third. So we actually have to, because the 6 is inside parentheses and everything inside is being raised to the third, the 6 is going to get that exponent. So it is 6 raised to the third, which is 216. So it's 216 times 1. We don't have to write the times 1. We're just going to leave it as 216. All right, now they're going to get a little more complicated, a little bit more going on. We know that with our order of operations that exponents should be taken care of first. So that's the first thing we're going to do here. Q to the third raised to the fourth. That's going to become q to the 12th because you're multiplying power of a power property. That's now going to get multiplied times this. This is q to the first. And so when those combine, that's going to be q to the 13th. And this 2 is just going to tag along, nothing going on there. 14, power first. So it's r to the second times s to the second. 5 is going to just hang out there. Now, where did the second come from? Well, really, this is a 1, this is a 1, and you're multiplying. Okay, and there's nothing else to do here, so that is my final answer. 15, I'm going to expand this power first. So that's going to be t to the 25th. When I multiply it here, I'm adding these exponents. So it's not going to change. It's still going to be t to the 25th. Another way to think about it is t to the 0. Anything to the 0 is 1. And so I'm really just doing 1 times this, which doesn't change it. So 3 is going to stay in front for our final answer. Okay, back to a pretty basic one here, just adding our exponents. So it's b to the 25th. 17, coefficients of -1 and 1, so it's going to be a negative. U to the 24th, this is u to the 1st, so that's u to the 25th. Nothing for v to be multiplied with, so v is just going to stay. 18, when I multiply -10 times 0.2, I'm going to get -2. X to the 5th, x to the 3rd is x to the 8th. W times w, that's going to be adding 1 and 17, so I get 18. X to the 17th, x to the 1st, that's going to be x to the 18th. Number 20, multiplying coefficients, that's 21. When I multiply similar bases, I add the exponents. So y to the 6th, z to the 6th, and actually y there is going to be 8, not 6, right? 6 and 2 give you 8. Okay, 21. 0.5 is like a half, so when I multiply by a half, I get half the number. So -12 times 0.5 is -6. Okay, this c to the 0, when I multiply, adding my exponent doesn't do anything, so I still have c to the 16th. And when I multiply here, I'm adding those exponents, so that is d to the 16th. 22. Multiply in your calculator, 0.875 times -16, you're going to get -14. And then dealing with your variables, e to the 1st, e to the 2nd, that's e to the 3rd. F to the 0 times anything's not going to change it. This is f to the 1st. It's going to stay f to the 1st. Remember, f to the 0 is just like 1, so it doesn't really matter. Or you could go ahead and add the exponents too. 0 plus 1 is just going to be 1, so it's f to the 1st. All right, multiplying here. Again, coefficients, you're multiplying. You just go ahead and multiply. So 9 times 9, that's 81. And I can't do anything with these because they are not similar bases, so they're going to stay separate. So it's g to the 2nd, h to the 3rd. Different variables, nothing you can do. All right, now this one always gets students. So I have to take care of my exponents first here before I start trying to multiply these together. This has to get squared. And since all of it is inside parentheses, that means the 10 gets squared and the I gets squared. So 10 squared is 100. 10 times 10. And then I also have I squared. That's getting multiplied by 0.01 I to the 9th. So when I go ahead and I multiply here, 100 times 0.01 is just 1. So if you want to write the 1, you can. And then I to the 2nd times I to the 9th is I to the 11th. So I don't need the 1, so you could just leave your answer as I to the 11th. Okay, number 25 again, 0.5 is a half, so multiplying by a half, you get half. 16 times 0.5 is 8. What did I miss? Oh, I made the deadly mistake of not taking care of my exponents first. So you can see that would be an incorrect answer there of 8. So I have to raise all of this to the 3rd power. Before I worry about multiplying these together, I have to take care of this. Order of operations, exponents first before multiplying. All right, so I'm just going to ignore this completely and just take care of this. So I actually have to raise 0.5 to the 3rd power. 0.5 raised to the 3rd power, and that's 0.125. And then when I raise these to a power, I'm multiplying my exponents based on that power to a power property. So j is going to be to the 15th. K is going to be to the 6th. Now I can multiply times this one. So I need to simplify my exponents, my powers, before I can go ahead and multiply these two things together. So it's going to be 16 times 0.125, and that's 2. And just combining these now, so j to the 10th and j to the 15th is j to the 25th, and 6 and 6 with my k's is k to the 12th.